Good morning, all of you. This is Priyanshu Choubey, Assistant Professor of Zoology and Bihar University. Today we will going to talk about soil physical properties like soil texture and structure. So let's see what is a soil texture. Physical property play an important role in determining soil's suitability of agriculture, environment, and engineering uses. The supporting capability, moment, retention, and availability of water and nutrients to plants, easy in penetrations of roots and follow of heat and air are directly associated with physical properties of the soil. Physical properties also influence the chemical and biological properties. The most parentate physical properties of soil relevant to its use as a medium for plant growth and discussed in the following section like soil texture is the first. Soil phases of the mineral soil mainly consist of discrete mineral particles as the amount of amorphous materials including organic matter is usually small. Mineral particles are not abstractly spherical but very widely in their shape. Therefore, these particles are usually classified into a three conventionally spherical groups according to certain size range based on their equivalent diameter. Diameter of a sphere that has a velocity of fall uh, in a liquid medium equal to that of the specific particles. The groups of different size range of mineral particles are known as separate primary particles or texture frictions, namely sand, silt, and clay. Soil texture refers to the prominent size range of mineral particles, and it's defined both qualitative and quantitative. Qualitative, it refers to the feel of soil, whether porous and gritty and fine, smooth when rubbed between thumb and forefingers. And quantitative soil texture is a relatively proportion of a sand, silt, clay content of weight basis. The term soil texture is often used interchangeably with a mechanical composition of soil. It is a more or less or static property affecting almost all other soil properties, land use capability, and soil management. Particles largely depends on the texture. So, classification of soil particles. Soil particles of size less than 2 mm in diameter are included in the classification and are considered as a soil material normally used in soil analysis. Some soil contains large size particles, which may create a problem in a tillage operation, but do not contribute sustainability to important soil properties. So, the particles greater than 2 mm are known as gravels. Uh, Gravel size almost 2 to 4 mm, and pebble size is 4 to 76 mm, and cobble size is 76 to 250 mm, and stone 250 to 600 mm, and still large, greater than 600 mm, like as boulders. Several systems exist for the classification of soil particles, but International Society of Soil Science (ISSS), renamed as the International Union of Soil Science, short form IUSS, and the United States Department of Agriculture (USDA). In this picture, Figure 5, USDA texture triangle picture are widely in used. Show this on slide. Some important properties of sand, silt, and clay particles are described here. In addition, sand and silt particles consist of primary minerals such as quartz and feldspar and mica, while clay particles are mainly secondary minerals. Uh, Secondary minerals such as kaolite, litellite, and vermiculites, morillonite, and chloride, hydride, oxide of iron and aluminium. So clay is a surface active frictions with a high degree of chemical and physical activity, while relatively entered sand and silt friction exhibit such activity to a lesser extent. The sand and silt may be called the soil skeleton, while the clay by analog regarded as the flesh of the soil. All the three frictions, including the pore space and between the form of the matrix of soil. System of a classification of soil particles according to their size. International Society of Soil Science divided in four particles: coarse sand and diameter 2.2202, and fine sand 0.2 to 0.02, and silt is 0.02 to 0.002, and clay is less than 0.002. United States Department of Agriculture particle size and diameter in mm. Particles vary coarser sand 2.0 to 1.0, and coarser sands 1.0 to 0.5 mm, and medium sand 0.5 to 0.25, fine sand 0.25 to 0.110, and very fine sand 0.10 to 0.5. Silt is 0.05 to 0.002, and clay is less than 0.002. So important properties of sand, silt, and clay particles. Uh, Sand properties visible to naked eyes, generally spherical and cubical shape, and feel gritty, lower water and nutrients holding capacity is very low and loose when and dry, very low plasticity and stickness when wet, and silt not visible to naked eyes, seen through an ordinary microscope, and generally spherical and cubical in shape, low to medium capacity to hold water and nutrient, feel smooth, some plasticity and stickness when wet. Clay visible only through a electron microscope and a platy shape, high water and nutrient holding capacity, hard when dry, and high degree of elasticity and stiffness. When wet, exhibit swelling and shrinkage behavior. Mechanical analysis for soil texture analysis, most important analysis or particle size analysis is a producer of determining the sand, silt and clay contents in the soil sample. So the primary soil particles, which are often aggregates and separated and made discreted by removing the binding agent like organic matter, calcium carbonate, soluble salts and oxide of iron and aluminium. In soil water suspension, the organic matter is oxidized with water, while carbon dioxide, calcium carbonate and oxide of iron and aluminium are removed by treating the sample with a dilute HCl and soluble salt by filtration with a distilled water. Mechanical steering is done to dispair the clay particles from each other and eliminated the air, and dispersing agent sodium hydroxide or the sodium hexa meta phosphate or calgon solution is added to prevent the clay particles to reunite. Once the soil particles are dispersed into ultimate particles, these are separated into a different size groups by shiving through a graded shivers up to approximately 0.05 mm in size. Sieves of a different size circular holes are used for a particle larger than 0 0.5 mm. For a smaller size particle, wire mesh screens are used. Mm, for still smaller particles less than 0.05 mm, method of the sedimentation is used, in which the relative settling velocity of particles or density of the suspension from which particles are settling is measured based on the principle of Stokes laws. Stokes laws G Stokes 1851. According to Stokes' law, the terminal velocity of spherical particles settling under the influence of gravity in a fluid of a given density and velocity is proportional to the square of its radius and uh, he gave one equation like v is equal to in bracket 2 upon 2 by 9 r square in small bracket ps minus pf bracket close g and upon velocity bracket close. So where v is a terminal velocity of the falling particle centimeter second inverse, and ps a density of solid particles, and gm3 and density of fluid gm centimeter 3, and g is a accelerations due to a gravity centimeter second square, and r is equivalent spherical radius of a falling particle centimeter, and is a velocity of the suspending fluid gram centimeter inverse second is inverse or the poise. uh, Adaptation and limitation of stock law. Adaptation and limitation of stock law: particles must be spherical, smooth, and gritty. uh, Raised, spherical, smooth, and raised. Clay particles are plate shaped and fall slower than spherical particles of the same mass. Size of particles must be larger than the size of the molecules of a liquid, that a Brownian movement of molecules of the liquid may not affect the falling velocity of soil particles. The large limit of the particles exhibiting a Brownian movement is approximately 0.002 mm. Therefore, in the gravitational field, particles from 0.10 to 0.0002 mm in size can easily be determined with the sedimentation method. Soil particles less than a 0.0002 mm size may be separated using centrifuge. So fall must be unhindered. Many fast falling large particles may drag finer particles down along with them. Particles falling very near the wall of container 0.1 mm destination distance are also slowed down in their fall. The concentration less than 3% of soil in the suspension vary. However, the reduces such hinders. Particle must be a uniform density. Density of a majority of mineral particles is in most soil varies between 2.6 to 2.7 gram centimeter cube, with an average value 2.65 gram centimeter cube, which can be used with reasonable accuracy. The suspension must be still without any turbulence. Particles greater than 0.05 mm in a diameter settle quickly and cause turbulence. Therefore are the analyzed using other producer. Any moment of the suspension alters the velocity of fall. Method of a mechanical analysis. That's a very important method. The international pipettes method and the hydrometer method are widely used for a mechanical analysis. The international pipette method is based on the principle of sediments, like a different size particle fall the different velocity. If a sample of soil water suspension in taken at the given depth at the particular time, it will contain all the particles which are still in suspension at that depth. The international pipette method is regarded as a standard method for a particle size analysis because of its accuracy, but it is time consuming. therefore usually not employed with a large number of samples to be analyzed. Hydrometer and Biocos 1927 method is based on the principle that there is a continuous decrease in the density of the suspension soil time that the rate of the particle fall below the level of hydrometer. The density of the suspension the progressively increase downward in therefore by measuring the density of soil suspension at the required times with a calibrate hydrometer, the proportion of the different sized particles can be determined. For quickly determining the silt and clay frictions, it has recommended to measure the density of the suspension at 4 minute and 2 hours respectively 368 Fahrenheit, and the hydrometer method is considerably fast and reasonable accurate but should not be used for a soil having a calcium carbonate. Organic matter content and salinity as the materials binding as the soil particles are not removed in this method. Texture classes the overall texture designated of the soil as determined from the relatively proportional of its sand, silt, and clay contents. It is called texture classes. Texture classes not only convey the texture composition of soil but also indicates their physical property. Soil based on their relative proportion of sand, silt, and the clay contents are classified into 12 texture classes on classes shown in this texture triangle. There and three bonds primary texture groups of soil, sandy, loamy, and clay describe texture in a relation to texture classes of the soil. To illustrate the use of textural triangle, assume that soil contain 40% sand and 45% silt and 15% clay by a weight. First, locate the point of the 15% clay on the left side of the triangle. Draw a line from this point across the graph parallel to the base of the triangular. Then locate the point for a 40% sand on the base of the triangle and draw an inward line from this point parallel to the right side of the triangle to the shoreline intersect at the point corresponding to 45% silt and line secting in the area demarked as a loam indicates texture classes of the soil sample like soil loamy. Texture group to describe a texture is a relation to texture classes of the soil. So texture group sand, loamy, clay. Sand texture coders, texture classes sand, loamy, loamy sand and loamy moderate porous and medium and moderate fine moderate porous sandy loam medium loam silt loam silt moderate fine sandy clay loam silt clay loam silty clay loam clay fine sandy clay silt clay and clay. So texture properties and behavior of soil. Sandy soils contain a more than a 70% of sand, less than 15% of clay, and a subdivision of two texture classes, sandy and loam sand. Sandy or porous structure, the soil are loose, absorb the water rapidly and drain is quickly. Well arid and aerated and can be worked easily in both moist and dry conditions. This soil are also called light texture soil due to a lower draft power required to till this soil is general the sandy soil have a lower water and a nutrient holding capacity. Lower organic matter content, no swelling, no shrinkage, poor sealing properties for ponds and dams, higher leaching of nutrient and polluted. The fine sands are easily blown by a wind. Fine corious sand risk erosion by water. Loamy soil. The loamy soil are sub divided in the seven structure classes: sandy loam, loam silt and loam silt, sandy clay loam and clay loam, silty clay loam. To qualify for the designation as a sandy or silt, soil must have at least of 40 to 50% of this separates. Therefore, a loam in which sand is a dominated classified sandy loam. An ideal loam is texture of sand, silt, and clay particles that exhibit the properties of these separates in the equal proportion. It does not mean that the three separates are present in equal amount. From agriculture point of view, loamy soil is the most favorable as its a capacity of retain water and nutrient is better than sandy, while its drainage, aeration, and tillage properties are more favorable than clay soil. However, under certain specific condition for some specific plants, species, sand or clay soil may be more suitable than a loam soil. The medium textured soil dominating in silt content have a medium to high water and nutrient holding capacity, moderate aeration, slow to medium drainage, medium to high organic matter content, and moderate leaching to pollutants and nutrients. So this soil are easily blown by a wind, susceptible to water erosion, easily compacted, having a slightly swelling and shrinkage and moderate difficult to till after rain. Clay soil, clay soil must contain at least 35% of clay frictions. These soils are further sub divided into three texture classes. If clay contains greater than a 40%, texture classes is either a sandy clay, silty clay, and clay depending upon the sand and silt content. Sandy clay contains more sand and clay content. Similarly, silt content of a silty clay is usually more than clay frictions. Clay or fine textured soil tend to absorb and retention more water than of the clay friction. Clay or fine textured soil tend to absorb and retain more water, become plastic and sticky when wet and hard and cohes- cohesive and when dry and difficult to cultivate are therefore also called a heavy textured um, soil. The clay soils have a high water and nutrient holding capacity, poor aeration, very slow drainage unless cracked, high to medium organic matter content, medium to high swelling and shrinkage characteristic. These soils resist wind erosion and also resist water erosion. When aggregate, these soil have a good sealing properties and rated leaching of nutrient or pollutants. Specific surface of soil. Specific surface is the surface area per unit mass per unit volume of soil, expressed as centimeter square gram inverse and centimeter square centimeter cube. Most of the chemical reaction are physical process like adsorption of water, swelling and shrinkage, plasticity and soil strength, cation exchange capacity, availability of nutrient etc. depends on a specific surface of soil. Specific surface increase as the size of the soil particle decrease. For a same volume of soil, the specific surface increase in the ratio in which the size of particles decrease. For example, if the size of cubical particles is 1 centimeter, then a specific surface area 6 meter square, 6 centimeter square and centimeter cube. If the cube is divided into 10, each of side 0.1 centimeter and 1 mm, then a specific surface will become 60 centimeter square centimeter cube. Thus, the specific surface area of sand particles of the 1 mm size and the cubical shape would be 60 centimeter square centimeter cube, whereas the clay particles of the 0.1 mm size would have a specific surface of the 60,000 centimeter square cube. Centimeter cube is that 1,000 times more specific surface than a sand particles. As the clay particles are the as the clay particles are plate shaped, therefore their specific surface would be given a higher beside the size and shape types of the clay minerals also affect the specific surface. The specific surface of soil separates the clay minerals and different uh, textured soils like the specific structure of the soil separates clay of soil separate clay minerals and different textured soil. So soil is separate soil, scorous sand. and diameter 2.0 to 2.0.2. Specific surface centimeter gram inverse 45. Clay minerals kaolinites. So specific surface is 37 to 45 meter square gram per inverse. Fine sand diameter 0.02 and 0.02. Specific surface 446 and clay minerals elite 120 to 170 milligram meter square gram per inverse. Silt 0.02 to 0.002. Specific surface area 4,458. Chloride 130 to 180 meter square gram inverse. Clay 10 to the power minus 4 and minus 10 to the power 2 to 10 to the power minus 6 thousand into 10 4 10 to 4 Montmorillonite specific surface area 580 to 758 sandy loam 10 to into 10 to the power 4 minus a 40 into 10 into 10 4 vermiculites specific surface area 780 to 90 loam 50 to 10 40 in 50 into 10 4 minus 100 into a 10 4 and clay is 120 150 into 10 4 minus 2 50 to 10 4. So here is a completed soil texture. Soil texture. What is the soil texture and method of mechanical analysis of soil texture. We talked about the Stokes law. Next slide we will be see a soil structure. Thank you.
Hello everyone, this is Priyanshu Choubey, Assistant Professor of Zoology and Bihar University. Today we will going to talk about a soil structure. Soil, what is a soil structure and uh, soil aggregates. So let's see what is a soil structure. Soil structure, it is a particular importance in the absorption of the water and the circulation of air. A desirable structure should have a higher proportion of medium size aggregates and an prescribable number of and an appreciable number of the large pores through which water and air can move. Structure of both the B horizon and the A horizon is a very crucial to a proper drainage in infiltration and productivity in soil with a poor structure root penetration in limited, thus the reducing the plant's access to water and nutrients. The structure of the A horizon has received a great deal of attention because of the its relation to seedbed preparation, B horizon potential aeration, water infiltration, overall soil health. So let's see soil structure. The primary soil particles do not exit as such. Um, such in a natural condition, but the bonded together into a large units of aggregates, usually termed as secondary particles. These aggregates formed under a natural condition are called pads. Where an irregular shaped coherent mass of soil formed during a tillage operation is called a clod. Soil structure is defined as the arrangement of a primary and secondary soil particle in a certain structure pattern. This arrangement result in information of different sized pores. Therefore, a soil structure may also be defined as the arrangement of the various sized soil pores in certain structure pattern. So now is the important of soil structure. Soil structure influence almost all the plant growth factors like water supply, retention, aeration, availability of a plant nutrient, heat, root penetration, microbial activity, and etc. Strong aggregations decreases decrease detachability and transportability of soil particles by water and wind, and thus reduce the runoff and soil erosion. Solid structure is useful for a classification of soils. It is affected by a tillage, cultivation, and application of fertilizer, manure, lime, gypsum, and irrigation. Classifications of soil structure. Uh, Soil structure is described and classified based on the types of the type as determined by a shape and arrangement. The class as a differentiated by a size, and third one is the grade as a determined by a distinctness and the durability of pads. So types of structure based on shape and arrangement of a pad. Solid structure is classified as a simple and the compounds, and simple structure, natural cleavage, planes are absent. Simple structure is of two types: uh, simple granite and massive. In single granite structure, particles are completely unattached to each other, as in case of a loose sand. And while in a massive structure, particles are the bonded in a large cohesion, non-structured mass. In case of a surface crust, plow, pane, and the clay pan. In compound structure, In compound structure, natural cleavage planes are visible with a naked eyes. This shape are individual paired and described according to relative length and vertical and horizontal axis by a shape and their edges. Compound structure is four types of depending upon a shape and their characteristics like first one, types of compound soil structure and their characteristics. Type one is a blocky all the shape and characteristics of a blocky, all the three dimensional of a pads are of about same size, providing a shape of a block having a flat and rounded face. These pads are further divided into a angular blocky and the subangular blocky. In the former face are flat and the edges and corner are sharp, while in the letterfish and the edges are mainly rounded. The blocky structure usually found in a B horizon and promotes good drainage, aeration, and root penetration. Second one is a prismatic. Prismatic, the pads are analogate more in vertical than in a horizontal direction. Given a column-like shape, vertical cleavage planes are the predominant. When the top of pads are relatively angular and flat, is called a